We're on section 3.3. We're talking about dividing polynomials. The first thing I want to talk about is, and let's just take a look at 38 divided by 7 and how we would go through the process of that. Now, if 7 goes into 38, we put it in 5 times, we get 35, remainder 3, right? That's old school stuff right there. So we could say that 38 divided by 7 is equal to 5 plus my remainder, which is 3 divided by 7, correct? Well, now let's take this equation here, 38 over 7 equals 5 plus 3 sevenths, and multiply everybody by 7 and see what happens. If I multiply everybody by 7, I get 38 equals 5 times 7 plus, again, these 7's cancel, plus 3. And what this says, this is equivalent to this one because we just used the multiplication property to call it multiply both sides by the same number. This is what we call the division algorithm. Okay, so I wrote the division algorithm here, which says if p of x and d of x are polynomials with d of x not equal to 0, then there exists unique polynomials, q of x and r of x, where r of x is not equal to 0, or the degree of r of x is less than the degree of d of x, such that p of x equals d of x times q of x plus r of x. That's really tough notation for what this says. If I take 38 divided by 7, that's the same thing as, hey, I have 38, and that equals, I was dividing it by 7, actually I put this backwards, I want to put it a little bit different, I was 7 times 5. 38, I divided it by 7, that was my dividend, this is my divisor. The quotient of 38 divided by 7 was 5 with the remainder of 3. Okay, so that's all this really says. Okay, so the division algorithm, and notice that r of x equals 0, that is the remainder equals 0, because it could, if I had, say, 35 divided by 7, my remainder would be 0. Or the degree of r of x is less than the degree of d of x. Notice that this remainder is always going to be smaller than 7, because if it was bigger than 7, I could have gone into it one more time, right? So the same thing here, the remainder, the degree of the remainder, it's a polynomial, we're going to be looking at polynomials, the degree of the remainder will be smaller than the degree of the divisor, okay? So that's something that we have to know. Alright, so I've got 2 examples here that we want to use the division algorithm for, and the process that we're going to do this by is called long division. Okay, so long division is very similar to we do long division back when you did it in 6th grade, very similar process. So let's take a look. So if I have this guy, this polynomial, divided by this polynomial, notice that the degree of this is bigger than the degree of this. Okay, we're going to divide this guy into this guy. Well, we take the divisor, x minus 4, we put it there, put my dividend inside a little quotient symbol. Okay, and then we go through the process. Now this is the process. The process says this. I'm going to ask myself, what do I want to multiply by to get x minus 4 at least 6x squared? Okay, what do I mean by that? Well, you remember this. Remember if I had, say, 3, it goes into, say, 61, right? I want to at least get the 6 here, and maybe it was 71. I want to get as close as I can to get this. Now, if I could get this, I'd do it. So I'd put it in, say, 2 times and get as close as I can, right? Now, if it was a 6, I'd want to make it so that it goes in 2 times, and I get 6 here, and I get remainder 0 for this part, then drop it down. Very similar to this one, okay? I want to multiply this thing by so that I at least get 6x squared. Now, what can I multiply x minus 4 by to at least get 6x squared? Well, the answer is 6x. Now, notice 6x, I'm going to put it right here over the x term, okay? X is go over x term, so 6x. Now 6x times x is 6x squared, and 6x times negative 4 is negative 24x. Now you will recall when you did this with just numbers, we subtracted downwards. Now I'm going to subtract downwards also, but the way I'm going to do it is I'm going to write this. I'm going to write minus, and I'm going to put a parentheses around this. I'm subtracting this whole thing. Now, because I'm subtracting this whole thing, what's that telling me I have to do with this minus sign? I have to distribute it. So really, I'm going to change this subtraction problem to an addition problem so that it helps me remember I got to distribute that minus sign. So if I distribute it, I'm going to put a plus here, a minus here, and change that to plus, okay? Because subtracting is the same thing as adding the negative. That's what I'm using right here. So then I have an addition problem. 6x squared and negative 6x squared, those goes to 0. Negative 26x and 24x is negative 2x. Okay? Now what I do, very similar to just numbers, is I drop that guy down. I'm going to put plus 12 right here. Right? I'm going to put plus 12. Okay, that was the plus 12, drop it down. And then I go through the same process. Ask myself, I want to get at least negative 2x. Well, what do I want to multiply this guy by to at least get negative 2x? Well, if I multiply by negative 2, negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. And what am I going to do downwards? I'm going to subtract downwards. It's very important that you put a minus and you put parentheses there. Because that'll help you to remember to distribute correctly. So if I distribute correctly, I'm going to change this from minus to plus. That changes this to plus and this to minus, correct? Now I add down. Notice that negative 2x and 2x will go away. 12 and negative 8 gives me a remainder of 4. Now, there's nothing else to drop down, so this is my true remainder here. So what's the answer then? Well, the answer is 6x minus 2, right? That's my quotient. Plus my remainder. What's my remainder? My remainder is 4 divided by what I had here is my divisor, x minus 4. Okay? Just like we did when we had our 38 divided by 7. The same process. Okay? Same process when we had a remainder. We had 3 as our remainder. We put 3 divided by 7 as our remainder term. And there we go. Okay? Let's try another one. Now this one, I've got a degree 3 polynomial and a degree 1 polynomial, okay? And I want to keep going until I have either remainder 0 or the degree of the remainder is less than the degree or equal to the degree of the numerator, which is 3. Now notice, by the way, guys, if we go back to this one, degree 2, degree 1, notice my remainder here is degree 0 up here, isn't it? Okay? All right, so let's go through this process. I have here x cubed minus 6x minus 8 under that guy, and I have x minus 4 here. Now I think you'll notice there's something weird about the way I wrote this, is I wrote this without an entry right here because it doesn't have an entry right there. But in actuality it does. Degree 3 term, degree 1 term, degree 0 term. In here I should have a degree 2 term. I'm putting one here now as a placeholder. And it's 0x squared. What is a placeholder? Guys, zeros are placeholders, right? For example, this means $101. Well, what happens if I didn't have the 0? Well, then you'd have a different symbol, right? We'd have one 100 and one $1 bill. But if I just wrote it like this, you wouldn't know, you'd think that is $11. So we need a placeholder there. Well, for division, we'd like to put a placeholder here. We have 1 of the x cubes, we've got 0 of the x squareds, we've got negative 6 of the x's, and negative 8 constant. Does that make sense? All right? So now we're going to ask ourselves, what do I have to multiply by x minus 4 by to at least get x cubed? Okay? Well, I think both of the answer to that, that's x squared, because x squared times x is x cubed. X squared times negative 4 is negative 4x squared. What am I going to do downwards? I subtract, which means I have to distribute. Okay, if I distribute the minus sign, okay, I'm going to distribute the minus sign, this becomes plus, that becomes minus, that becomes plus. So I'm adding down now, and I get 4x squared here. The x cubed terms cancel out. I drop down my negative 6x, oops, that should be squared, excuse me, little typo. Drop down my negative 6x. What do I want to multiply this guy by to at least get 4x squared? Well, I want to multiply it by 4x. So I put plus 4x here. 4x times x, 4x squared. 4x times negative 4, negative 16x. I'm going to subtract the whole thing going down. Very important to put the parentheses. What do I do with that minus sign? Rhymes with distribute. So I'll put plus, minus, plus. Those two cancel out. These two give me 10x. Drop down my minus 8. What do I want to multiply by to at least get 10x minus 8? Well, I want to at least get 10x. I want to multiply by 10. So I multiply this thing by 10. I'll get 10x. X 10 times negative 4 is negative 40. I'm going to subtract all the way down. Okay, distribute the minus sign. Plus, minus, plus. Add down gives me 32. So my remainder now is 32. So the overall answer will be x squared plus 4x plus 10 plus, what's my remainder? 32 divided by my divisor, x minus 4. Okay? So there we go.